going to do is we're going to start here with a question, and if you can wait for the microphone and give your name and affiliation, and then we'll go to the phone lines. Sir?
Randy Shostak, reporter with EOS, newspaper of the American Geophysical Union. This is very interesting information, and so I guess I have sort of a basic question. I'd appreciate if you could describe further the other models that you investigated and explored and perhaps discarded. What are the weaknesses in those models for describing Europa? And do you believe that the model that you've outlined today is the only model that now is useful in describing Europa sufficiently, or could there potentially be other models that might be useful here?
Well, certainly. For a long time, we've thought that chaos terrain is formed in the presence of some amount of water. One of the key unknowns is how you get those surfaces like Connemara chaos to actually produce domes up above the surface. It's actually very hard to do with most models. There have been a couple of models suggested. I'll highlight two of them. One is that you completely melt the ice shell and that the matrix material represents places where liquid water flowed on the surface. That has some problems just because of the cold surface temperatures of Europa and because other observations of Europa suggest that the shell is incredibly thick. On the other hand, there's been models of convection and diapurism where the goal was to try to look at if plumes could survive up into the surface ice to cause that doming. Well, if you relax that constraint and think about what happens when ice actually gets heated, is it melts. And so, in fact, the opposite of what originally was the goal happens, and that as the ice melts, it contracts and causes the surface to depress. But what that also does is it gives a chance for the surface to break up, to fracture, just like ice shelves on the Earth. Why that's important is that we see icebergs on Europa seem to follow pre-existing lines, fractures that already existed. So it's like it's being opened up from the bottom, water's getting in there and breaking off those chunks of ice. When you do that, you mix up all the other stuff. We mentioned a mosh pit of ice earlier. As those big, strong icebergs move around, they can break up all of the weak ice in between, which can fill with water, still not be liquid, but fill with water. As you freeze that out, the expansion happens again. So just as the ice, when it melted, caused thermal contraction, when it refreezes, it causes thermal expansion. And that gives you the extra boost needed to kind of pop that surface back up into a dome. Because you've entrained salt-rich water into that matrix material, creating that kind of lumpy texture on the surface. So it's not the only model that's out there, but one of the exciting things about it is that it does kind of explain why we see icebergs, which might seem to make you think that the ice shell is thin, but also this matrix material in these domes, which indicate the ice shell is thick.
Okay, let's go to the phone lines, and we're going to head out to the West Coast with David Perlman from the San Francisco Chronicle. David?
Hey, thanks very much. Just two questions quickly. One is NASA seems to have placed a priority in the search for life on these Jovian moons and others, and Enceladus and Titan seem to be the higher priority targets. Are you people making a pitch for more attention being paid to Europa? And if so, how do you make that pitch besides a forum like this? And incidentally, is this theory about chaos terrain being published, or has it been published in the literature? And I'll take the answer right now.
Well, I think what we're saying is that Europa continues to be an interesting priority for exploration, which it has been for 30 years or more. Yes, the paper has been published. It was just released, advanced online publication by Nature today, and will appear in the print version of the magazine next week.
Can I just add to that? The National Academy of Sciences published a decadal survey for exploration, which was the science community giving NASA its suggested priorities for exploration over the next decade. and I was actually part of the satellites panel that looked at both Titan and Europa, and they are both considered to be extremely important targets, and both have astrobiological potential for different reasons. But at this time, that panel felt that Europa was more compelling, partly because Titan does need some technology development to do certain types of missions there. So they are both very important targets, but at this time it was felt that the recommendation from that panel was that perhaps Europa was of a higher priority at the moment.
Okay, I actually have two questions here. The first one is for Brittany from one of the .coms, and then for Tom Wagner. So the question is very simple. What are the next steps with presenting this and the data that you have now?
I'm glad to answer that question. For us, the next steps with understanding chaos formation and whether this lake model really is correct is to look at the entire surface. There's still data to be used in the Galileo archives that we can use to compare this model to other models and really rigorously test it. And then we'll be ready to go on and test hypotheses in the future with exploration.
The other question from one of the .coms, as the Earth scientists, personally, what are your feelings on what you're seeing here and how it relates to your research?
Oh, I think it's fantastic. You know, we don't have that many of these examples even on the Earth of ice shelves collapsing. So anytime we can go and see something like this, and also the scale is tremendous. You know, that's one of the things. The Europa scale is a little bit bigger, but that in the future may be something that's more relevant to us here on Earth. So I think it's an exciting research example for us to continue to work together on.
You have any other questions here? Go ahead.
I guess I'd just like to follow up on that last question that was asked in your response. During your presentation, you talk a lot about what the Earth might help us to, how the Earth might help us to understand Europa. If you can elaborate a little bit more on how Europa might help us to understand more about Earth processes.
Yeah, sure. You know, one of the big things is we're kind of in a new state on the planet, you know, and when we try to understand, say, the Pine Island area, and we try to understand that large ice shelf and how it's going to interact with the ocean, one of the theories right now is this, that you've got lack of sea ice and anomalous winds blowing warm water up onto the continental shelf around Antarctica, and that's causing the ice shelves to thin, and that's causing some of them to destabilize and break up. Well, we've seen that happen, but we've only seen it happen right now in kind of small places around the fringe. How is it going to happen in bigger places? You know, what's going to happen as that warm water gets in deeper? And so something that we're going to get are just simple things, even like geometric constraints, right? Like, you know, what's going to happen to a really thick area as it breaks up? And something that I didn't talk that much about, the Wilkins ice shelf that I showed first, the reason for that's so interesting is that it was kind of mechanical breakup in that the ice shelf had flowed out, and as it flows out in the ocean, it gets thinner and thinner and thinner. Just like I say, picture it like spreading pancake batter. You know, it just gets thinner as it goes out, and then eventually destabilizes and breaks up, and it triggers. With the Larsen ice shelf case, one of the theories is that you had surface melting. So you had warming of the surrounding area, water formed, and then kind of like the Europa example, except kind of in the reverse way, that water percolated down, forced its way through cracks, created cracks, destabilized the ice shelf, and it could break apart along those things. So there's, you know, those are kind of two end member cases that we're trying to test between, and Europa is now another example for us to think about.
Okay, what we're going to do is, actually, they've done such a great job explaining it. We have no further questions on the line, although we have numerous media that are listening in, so I want to thank you all for joining us. Obviously, information, go to www.nasa.gov, and thanks for joining us. Science never